Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Hello, hello, hello. Lesson 17, the side angle side, SAS, and side, SSS criteria for two triangles to be similar, not congruent, similar. Okay, opening exercise. Choose three lengths that represent the sides of a triangle. Draw the triangle with your chosen lengths using construction tools. Okay, so let me choose some sides. 4, my pen? 4, 5, and how about 10? Okay, I'm doing this on purpose. It does matter what values you choose, because watch what's going to happen now. I chose side lengths of 4, 5, and 10. So I'm going to quickly draw a segment of length 10. The longest side first. Okay, and then I'm just going to rotate my ruler, and now I'm going to draw a side length of 5. There's 5. Then I'm going to move my ruler to here and draw the last side length of 4. So it's got to go to here, correct? So I go out 1, 2, 3, 4. Whoops. It doesn't reach. To put it in simplest terms, the shorter two sides have to add up to more than the longest side. 4 plus 5 is 9. This is not long enough to create a triangle. So then if I get rid of this 10, and it can't be 9 either, because 4 plus 5 is 9, and this would be right on top of that same length. That would not be a triangle. So this has to be, the third side has to be less than the sum of the other two sides. So 4 plus 5 is 9. What is going on with my pen? 4 plus 5 is 9. Sorry about this, my pen's wacky. 4 plus 5 is 9. I need something less, so let's do 7. So if I put my ruler back right here and shorten the longest side to 7, so I'll get my eraser and erase back to 7, like so, and then delete this. Now the side 5 and 4 will reach. Okay, but I can't just put it anywhere. The easiest way to create this after I draw a side length of 7 is taking a compass putting it at 0, opening it up to one of the side lengths. Let's do the 5 first. So there is 5 right there. And I'm going to draw an arc. So somewhere on that arc will be the distance of 5. Then you move your compass over here to 7, rotate it, flip it, open it up to the other distance. So this was 5, now I'm going to do 4. So 7 minus 4 is 3. And I draw an arc. Where those two intersect will be where my other vertex should be. So when I rotate this up, this is length 5. And then when I bring my ruler up here and rotate this down, you will see that it is length 4. Okay, so there's a triangle with side lengths 4, 5, and 7. Okay, so this is 7. This is 7, this is 4, and this is 5. So there we have part A. Part B says, multiply each length in your original triangle by 2 to get 3 corresponding lengths of sides for a second triangle. Draw your second triangle using the construction tool. So if I take R times my sides, 4, 5, and 7, then I'm going to double it. So my R is 2. I'm struggling this morning. That's going to be 2 times 4, which is 8, 2 times 5, which is 10, 2 times 7, which is 14. So my new sides are going to be 8, 10, and 14. So I'm just going to move this over here so it's not in the way. I have no idea what just happened there. Okay, hang on. Okay, so the sides are going to be 8, 10, and 14. So let's draw the first side of length 14, 0 out to 14. Okay, and then I'm going to get my compass, put it at one end. Should have left my ruler there. Okay, so I'll do the size 10. Wonder if this will open out to 10. No, of course not. Okay. So let's do the size 8 first. Somewhere on this arc will be a length of 8. Move it over to 14. How am I going to do this? My compass doesn't open far enough. It only opens to here. I need it length 10. So here. So the only way I could do this, since my compass isn't big enough, is move this over here, rotate up, and find where, I guess I could use my ruler to do this. This is the distance of 8. I need 10. So I rotate, yes, I need 10. So it is way over here somewhere. But I need it from here. So that's wrong. This is the end of my 14. And my length has to be 10. So I just rotate my ruler down until I get to the point where 10 touches the arc, which is right here. So this is a side length of 10. Whoops. Why is that not recognizing my ruler? Huh. Usually it grabs right onto the end of the ruler, like so. It's not recognizing this side. There it goes. Struggles are real this morning. Let me do it this way. Okay. I have a defective ruler. Unreal. Never had that problem before. Let's clean this up. Get rid of this arc. Now this is 14, this is 10, and this is 8. Draw your second triangle using construction tools. Okay, done. So there you have it. All right. Okay, page 2 brings us to answering some questions about what we just did. And it says, do your constructed triangles appear to be similar? Explain your answer. So if I go back and I look at this, these are flipped around. So this, my longer side is 5, which is here. This is 10. 5 times 2 is 10. 7 times 2 is 14. 4 times 2 is 8. The length's doubled, so there is a proportion. And this angle looks like this angle. Let me label them because I rotated. So this angle is congruent to this angle. This angle is congruent to this angle. So if you have two congruent angles and the sides are proportional, then they're similar. So I would say, yes, these look similar to me. And so here's my answer. The triangles appear to be similar. Their corresponding sides are given as having lengths in the ratio of 2 to 1, and the corresponding angles appear to be equal in measure. This can be verified using either a protractor or patty paper, which I'm not going to do, but anyhow, we'll move on. D, do you think that the triangles can be shown to be similar without knowing the angle measures? Okay, so the only thing I would say about that would be, if you're not going to measure the angles, the only other way we could do this would be if I rotate this, and let me do it. Okay, so I flipped these over the way they should be. Just I did a reflection. And then if I chose one of the sides and drew a ray, and then did it for the next, and drew a ray. If I continue these the other way, why is my ruler doing this? Let me delete my ruler. Okay, so it says, do you think the triangles can be shown to be similar without knowing the angle measures? Well, here's what I did. The only other way we could really do that would be to connect the corresponding parts like so, and then go up and see if they share a common point of dilation. So that would be the only other way we could show similarity, I think, without actually measuring the angles. All right, exploratory challenge number 1, exercise 1 and 2. It says to examine the figure and answer the questions to determine whether or not the triangles shown are similar. What information is given about the triangles in figure 1? Well, we are told that angle A is shared in both triangles, so they're congruent. We don't have a second angle. We have a side length of 4, a side length of 9, a side length of 3, a side length of 6.75. Okay. So putting that into words, we're given that angle A is common to both triangles. So therefore A is congruent to itself by the reflexive property. And we are also given information about some of the side lengths, and that's it. B says, how can the information provided be used to determine whether triangle ABC is similar to triangle A prime, B prime, C prime? So we know that the similar triangles will have ratios of corresponding sides that are proportional. Therefore, we can use the side lengths to check for proportionality. Page 3, part C, compare the corresponding side lengths of triangle ABC and triangle AB prime, C prime, and what do you notice? Okay, so I'm going to go back and look at the values here, and let me copy this and bring it to the next page so I don't have to keep going back and forth. Okay, so here's that diagram from the prior page. All right, so if we're going to compare parts, I'm going to put AB is to BB prime as AC is to CC prime. And when I do that, then I substitute in my values. AB is 4. B prime is 9. Set that equal to AC, which is 3. CC prime is 6.75. So when you have a proportionality, when you set two ratios equal to each other, it is a proportion. If I cross multiply, like so, I get 9 times 3 equals 4 times 6.75. 9 times 3 is 27 equals 5 times 4 is 20, carry the 2. 7 times 4 is 28, plus 2 is 30, carry the 3. 6 times 4 is 24, plus 3 is 27.00. So 27 equals 27, so we do have a proportion. So then you'd say the cross products are equal, therefore the side lengths are proportional. Okay, so part D says, based on your work in parts A through C, draw a conclusion about the relationship between the two triangles. So it says the triangles are similar by the triangle side splitter theorem. Remember that? I know that when the sides of a triangle are cut proportionally, then BC is parallel to B prime C prime. Then I can conclude that the triangles are similar because they have two pairs of corresponding angles that are equal. Okay, so since these sides were proportional, then we know this BC is parallel to B prime C prime, and with that, we have that side splitter theorem. So we now know, for example, this angle here is equal to this angle here, because parallel lines cut by transversal corresponding angles are congruent, and we have the angle. Okay, number 2 says to examine the figure and answer the questions to determine whether or not the triangles shown are similar. What information are you given about the triangle in figure 2? Well, again, we're given a shared angle and we're given side lengths. So it's the same setup as the previous. Okay, so we're given that angle P is common to both triangles, and we're also given information about some of the side lengths. Okay, page 4, part B. How can the information provided be used to determine whether the triangle PQR is similar to PQ prime R prime? And the answer is, we know that similar triangles will have ratios of corresponding sides that are proportional. Therefore, we can use the side lengths to check for proportionality. Compare the corresponding side lengths of the two triangles, and what do you notice? So we're talking about this figure here, so I'll bring it over to the other page. Okay, so here we go. Here's the diagram, and we're going to compare these. So this one I'm going to do differently. The last one I did this side is to this piece, as this piece is to this piece. This time I'm going to do PQ is to PQ prime, the whole thing. And it has to equal PR with respect to PR prime. So PQ is 3. PQ prime is 3 plus 10, 13. Don't forget to add them. PR is 2. PR prime is PR plus RR prime, or 2 plus 7, which is 9. 13 times 2 is 26. 9 times 3 is 27. And then we go, ruh-roh, those are not equal. Therefore, these triangles are not going to be similar. Part D says, based on your work in parts A through C, draw a conclusion about the relationship between the triangles and explain your reasoning. Okay, so here it is. The triangles are not similar. The side lengths are not proportional, which is what I would expect in similar triangles. I know that the triangles have one common angle, but I cannot determine from the information given whether there is another pair of equal angles. Therefore, I conclude that the triangles are not similar. Exploratory challenge 2, exercises 3 and 4. Number 3 says, 2, examine the figures and answer the questions to determine whether or not the triangles shown are similar. Okay, so we don't have any angle measurements, but we have all of the side lengths. So I'm going to set up a proportion. So I'm going to say AB is to A prime B prime, as BC is to B prime C prime, as AC is to A prime C prime. And then I'm going to fill in my information. So AB is 2.82. A prime B prime is 1.41. BC is 7. B prime C prime is 3.5. AC is 5.4. And A prime C prime is 2.7. Well, if I take 2.82 and divide it by 1.41, I get 2. 7 divided by 3.5 is 2. 5.4 divided by 2.7 is 2. Okay. And again, I've made this mistake. You just need to be aware when you're done to take the reciprocal. I always forget this, but if you think about what you're doing when you're done with a problem, R does not equal 2. I should have put the image in the numerator and the pre-image in the denominator. So if I flip these all over, it'd be 1 over 2, 1 over 2, 1 over 2. And that would be what our R equals. So we have this was scaled down a half and rotated. Okay, so since we have a proportionality, we have to assume that the angles, corresponding angles, are congruent. So angle A should be congruent to angle A prime, and so on and so on and so on. Okay, page 5 brought us to part B. So then I realized, where did part A go? So I'll go back. It is right here. And it says, what information is given about the triangles in figure 3? Well, the only information that is given is the side length measures. Part B says, how can the information provided be used to determine whether triangle ABC is similar to triangle ABC prime? So, give me a moment here. We know that similar triangles will have ratios of corresponding sides that are proportional. Therefore, we can use the side lengths to check for proportionality. So I've already done this. I got ahead of myself on the last page. It says to compare the corresponding side lengths of triangle ABC and triangle AB prime C prime. And what do you notice? So here's what we noticed. I'm just making it neater by the typed version. And we have all the side lengths equal, and they end up all being equal to 1/2, and that is our R, our scale factor. D says, based on your work in parts A through C, make a conjecture about the relationship between these two triangles. So with that information, knowing the sides are proportional, I would then say, I think the triangles are similar. The side lengths are proportional, which is what I would expect in similar triangles. Okay, so number 4, moving along, example in the figure. Examine the figure and answer the question to determine whether or not the triangles shown are similar. Okay, so again, I'll do it in the right order this time. So it's going to be questions like this on the next page. So here's the figure. I will copy it and bring it over to the new page. Okay, so I brought the figure over here to the new page. Let's scroll up a little. So this is the figure we're going to use for these questions. A says, what information is given about the triangles in figure 4? And the answer is we're only given information related to the side lengths of the triangle. We do not know any angle measures are congruent or any angle measures, period. B says, how can the information provided be used to determine whether the triangles are similar? So what do we know? Notice the repetition in this lesson. We know that the similar triangles will have ratios of corresponding sides that are proportional. Therefore, we can use the side lengths to check for proportionality. Okay, so here's how we're going to do that. I'm going to use purple this time. All right, so if I'm going to compare, I'm going to do it right this time. Your image always goes in the numerator, your pre-image in the denominator, because we're going from here to here. If the image is bigger, then the scale factor is greater than 1. If the image is smaller than the pre-image, then the scale factor is less than 1, but greater than 0. So in setting that up, I would say A prime B prime is to AB as B prime C prime is to BC as A prime C prime is to AC. In setting those up, then I'd have A prime B prime is 2.1. AB is 1.41. And then we would say B prime C prime, which is 8.29, is to BC, which is 6.04. And set that equal to A prime C prime, which is 7.28. And compare that to AC, and AC is 5.25. Okay, these are not visibly double or anything like that. So I'll use my calculator. So I'll say 2.1 divided by 1.41 equals an ugly number. Okay, that is, it's probably rounded, it's probably irrational. So it's 1.4, what was it? 89. 1.489. So this is almost 1.5. This is almost 2 to 3. So then we say equals, and I use that term loosely now because if they are equal, then these three are all equal, then it's going to be similarity. But if they're not, it isn't. So then I'm going to take my calculator and say 8.29 divided by 6.04 is, and I got 1.373 rounding. 1.373. Well, these are not equal. So I don't even need to do this last one. I don't even care, because I know that these two are not in proportion. So therefore, these two triangles are not similar. All right, so in answering this, we would say, I think that the triangles are not similar. I would expect the side lengths to be proportional if they were. Okay. All right, exercise 5 through 10 says, are the triangles shown below similar? Explain. If the triangles are similar, write the similarity statement. Okay, so again, we're going to set up a proportion. And when they don't use the A, B, C, and the primes over here, we assume that the A, B, C, starting in alphabetical order, would be our pre-image, and the D, E, F would be our image. So the D, E, F goes on the numerator. So if I'm comparing, then I'd say DE is 2, and DE is this side. So it's obviously not AB. ABC, and then they're calling, so it looks like D corresponds to C. So first I'm going to name these triangles ABC. And then C is this angle here, and that looks like D here. So you need to make sure you're naming these correctly. A is obtuse, F is obtuse, so it has to line up when we name it. And then finally, we have the E by process of elimination. So DE is to CB. See how I'm doing this? Once you figure out how to name these, DE is to CB as EF is to, and notice it's EF, middle first is BA, is to, and then finally DEF, we don't have DF. So if I put DF last first, CA is last first, so CA. So that's how you set up the proportion carefully. Name the triangles and make sure each corresponding part is the one that appears to be congruent. We can't say congruent yet. All right, so how long is DE? It's 2.42. How long is CB? CB is 6.4. We are assuming they're equal, so I'll put equals. EF is 0.68. BA is 1. And DF is 2.13. And CA is 5.83. Okay, plug these into my calculator. 2.42 divided by 6.4, and I get 3.78, 0.378. That has to be equal to 0.68 divided by 1, and I'm having my doubts. That's 0.68, right? Anything divided by 1. All right. And then finally, obviously, 2.13 divided by 5.83 is 0.365. Okay, so obviously 0.37 is not equal to 0.68, is not equal to 0.365. So I will do this, and then I'll bring in my conclusion. And that is going to say, there is no information about the angle measure, so we cannot use AA or SAS to conclude triangles are similar. Since the side lengths are not proportional, we also cannot use SSS to conclude the triangles are similar. So therefore, the triangles shown are not similar. All right, page 7 brings us to problem number 6. What do we have here? It says, are the triangles shown below similar, and explain. If the triangles are similar, write a similarity statement. So we have an angle of 75.96. So B is congruent to E. And we have two side lengths. So I'm going to call ABC my image, my pre-image, and the little one my image, because we go in alphabetical order generally. And you always put the image values in the numerator and the pre-image in the denominator to determine our scale factor. So before I do this, I'm going to name these triangles so my parts correspond. So if I call this triangle ABC, then the other triangle is going to be called, don't just say DEF automatically, you have to check. So the first thing I do is look at corresponding parts. We know B is congruent to E, so E has to be in the middle because B is in the middle of our naming. AB is shorter than BC. So which side is shorter here? DE is shorter. So A corresponds to D. So this is ABC and DEF. Okay. So the first thing we want to do is compare sides. So I can do triangles, the same size from this triangle compared to this, or I can do corresponding side to corresponding side. Either way, it doesn't matter. I will do AB over BC equals, and if I said AB, I have to say DE over BC. BC is the same as EF. And then I substituted my values. AB is 3. BC is 3.13. And they have to equal the proportion between these sides. And DE is 1.5. And EF is 1.565. And then I cross multiply. So just to save time, I'll use a calculator. 1.565 565 times 3 equals 4.695. And that has to equal the other cross product, 3.13 times 1.5. And I got the same number, 4.695. So we have one angle congruent to another, and we have proportional sides. So now we can conclude. Okay, so our response to this would be yes, the triangles shown are similar. Triangle ABC is similar to triangle DEF by side angle side because the measure of angle B is equal to the measure of angle E and the adjacent sides are proportional. So it was a side included angle side. Number 7, are the triangles shown below similar? Explain if the triangles are, write a similarity statement. Okay, number 7. So first thing I like to do is I always like to name the triangles. So off to the side, I'll say triangle ABC. And triangle, well, A corresponds to A, right? A is shared. So A is in the big triangle too. D corresponds to B. And C corresponds to, or E corresponds to C. So the little triangle is ADE and the bigger triangle is ABC. So we could either look at it as being scaled down from the big one to the little or scaled up from the little one to the big one. I like going alphabetical order. I would say ABC was our pre-image and triangle ADE is our image. So this was scaled down. So I put the pre-image in the denominator. So if I choose a side, let's see. First, what are we given here? We aren't given any side lengths. So let's not look at sides. We're given this angle is congruent to this angle. Okay, so what does that tell us? Well, I think we may have a side splitter here because if we have corresponding angles congruent, then the sides have to be parallel. The other thing we can look at is the measure of angle A. A is shared. And since A is shared, A is another congruent angle in both triangles. So angle A is congruent to angle A and angle D is congruent to angle B. So therefore we have angle-angle similarity. So we're done right there. So here's what we can say. Oops. We can say, yes, the triangles shown are similar. Triangle ABC is similar to triangle ADE by angle-angle because the measure of angle ADE is congruent to the measure of angle ABC and both triangles share angle A. And number 8, are the triangles shown below similar? Explain if the triangles are similar, write a similarity statement. So now we are given an angle and an angle. Okay, so we have right angles. So angle A is congruent to angle E. And it looks like we have, notice where these sides are. We have this side, and we have this side, and this side, and the angles included. So this could be SAS. That's from the information we are given anyway. So we're going to set up a proportion. So first thing I always do is name the triangle. Triangle ABC is this big one. And triangle, so A is the right, so here it is E. So be careful naming these. Just don't name them alphabetical order. They label this differently. A is a right angle. E has to be a right angle if these are similar. A goes with E. AB is shorter than AC, and I said AB, so I want to go the direction of the shorter, so EF is shorter than ED, so I have to name this EF, and then therefore D here. So C is this angle, D is this angle, F corresponds to B, just like in the naming here. So after getting that straight, then we can easily set this up. So this is my pre-image, this is my image, pre-image goes in the denominator. I'm comparing AB to EF, AB, EF. See how the names line up? And those have to equal, and then I'm going to compare AC. So I know AC And AC is first, last is ED. Okay, so EF is 1. AB is 3. Equals ED 3. And AC 5. Okay, well, 1/3 and 3/5. 1/3 is 0.33, and that does not equal 0.6. I can just tell, I know fractions, because if you double this, it'd be 6/10. There's 6/10. 1/3 is 0.33 repeating. They are not equal. So I can conclude these two triangles are not similar, even though we had side angle side setup and one angle in common. We cannot always say that triangles are similar. So I'm going to bring in this very lengthy explanation. Okay, here we go. Phew. There is no information about the angle measures other than the right angle. So we can't use angle to conclude the triangles are similar. Check. We only have information about 2 of the 3 side lengths for each triangle, so we cannot use SSS. Agreed. If the triangles are similar, we would have to use SAS criterion, which is what I had drawn up over here. I had said, looking at this by looking at the diagram, side angle side would be our only possibility. And since the side lengths are not proportional, however, not equal, the triangles shown are not similar. So it says here, note that students could also utilize the Pythagorean theorem to determine the lengths of the hypotenuse. Yes, you could. 3 squared plus 5 squared, 9 plus 25 is 36. Isn't it? No, 34. So this would be the square root of 34. 3 squared is 9, 1 squared is 1, 9 plus 1 is 10. This would be the square root of 10. Booyah! So then we could check side, but it doesn't matter. We don't have a proportion. Page 9. Wow, this is a long lesson. Whew. Or is this page 8? Been so many. It's page 8. Number 9. Okay. About ready to lose it here. Hang in there. Number 9. Are the triangles shown below similar? Explain. If the triangles are similar, write a similarity statement. So the first thing I always do is, hopefully you know this by now, name the triangles. So I have one triangle, PQR. I have a second triangle, and P corresponds with X. Q is my obtuse, so Y is the obtuse, lines up, and then R is this really small acute angle that corresponds to Z. So PQR corresponds to XYZ. All right, so there are no angles given, so this will not be angle. This will not be side angle side. Only possible thing is side. So that's the first thing I look at. Okay, we're going to try to prove these two triangles are similar by side by setting up a proportionality. So my pre-image is going to be, I don't know, probably PQR because it's alphabetical order. So I'm going to say PQ is to QR is to RS. Oops, I'm sorry. No such thing. It's not a square or a rectangle. PQ is to QR is to RP. So I'm first naming all the sides in my pre-image in the denominator. So then I like looking at the name. I don't even look at the diagram anymore. I use the names to line up the proper names up here. PQ, XY. QR, second, third, YZ. RP, last, first, ZX. Okay, then I just fill in the blanks. XY, XY, 2.7. PQ 3.6 has to be equal to YZ 5.46 divided by QR 7.28, and that has to equal ZX, which is 7.5 divided by RP 10. Okay, so that's that. Now I get my calculator out. And 2.7 divided by 3.6 equals 0.75. So that reduces to 3/4, 0.75. Then we go in and we do the next one, 5.46. 5.46 divided by 7.28, enter. And that is also 3/4. So I write 3/4 equals, well, 0.75 divided by 10 is obviously 3/4. Look at that, they're all equal. We do have a proportion and it's because of side, side, side. So here's what I would say. Yes, the triangles are similar. Triangle PQR is similar to triangle XYZ by SSS. Number 10. I think this is the last problem in this very long lesson. Hang in there. We're almost done. Are the triangles shown below similar? Oh, well, let's see. We have an angle here congruent to an angle by vertical angles being congruent. We have a side that forms that angle here that would correspond to this one. We have a side that forms that angle there that corresponds to this one. Okay, because if I name these triangles, let's name them. Triangle ABC, ABE, just kidding. Let's erase that C. ABE, triangle ABE corresponds to triangle, let's see, since E comes last, it's going to be last here as well. So I just need to know if I call it CDE or DCE. So A looks almost right, and that is our D. So it's going to be triangle DCE, ABE. BE, I said last, that's my red segment, corresponds to CE, the red segment. So everything's all set up. You want to do this first so that we set up our proportionality. We have two sides and an included angle. So we're going to try to prove these are similar by SAS. So here we go, set up a proportion. So I'm going to compare three sides, obviously. So I just set this up. Look at your pre-image, side AB, and then we have side BE, and then we have side AE or EA. Doesn't matter how you name the first one, you just have to correspond parts. AB is to DC, BE second, third, CE, and then AE, first, last is DE. So that is our proper setup, and then we fill in our numbers. AB, don't know it. We only have two sides, so why am I doing three? Good question, but that it just helps you set it up. CE, 6.32. is to BE, 3.16, equals, well, I already know that that's half. 3 times 2 is 6, 16 times 2 is 32. This is a 2-to-1 ratio, and I'm going to write that right there. We already know that the scale factor R is 2-to-1, or just simply 2. Okay. Why am I yeah, 2-to-1 or 1/2. Did I do this wrong? ABE is my pre-image that goes in the denominator. Yeah, it's scaled up, scale factor of 2. I was right. Keep going. Don't question. AE 2.24. What in the world? What? 2.24 is to AE. AE is 2.24. Delete. Let's try that again. I have been really struggling today, and this is a long video, and that always tends to happen. So AE is 2.24, and DE is 4.48. Well, 2 times 2 is 4, 2 times 2 is 4, 4 times 2 is 8. That is also 2-to-1. They are equal. We could cross multiply and check, but it's clear when we have a 2-to-1 proportion or that there is a similarity. So now I'm going to say, I think I already did it. Let's see, where is it? Right here. Yes, the triangles are similar. Triangle ABE is similar to triangle DCE. Okay, so notice how we named it correctly, and it's got to be said in that order. By SAS, because the measure of angle AEB equals the measure of angle DEC. Vertical angles are congruent, and the sides adjacent to those angles are proportional. Okay, page 9. Yes, page 9 brings us to the end of a very lengthy lesson 17. If you've watched this video from start to finish, take a break, but then go do your problem set.